In today's lesson, we're going to introduce a topic called slope. You might have heard the word slope used in reference to the steepness of things. For example, what's the slope of a roof? Or I hit the slopes, as in you're going down a hill on skis or something like that. Or you might have seen a sign along the road that looks kind of like this with a picture of a car or a truck that's driving downhill with a percent symbol like that. That percent symbol refers to the slope. Now I'm going to use this idea to describe the words positive, negative, zero, and undefined for our lines. On this, let's pretend for a second that we were driving a truck on a road that follows this line. And when we are looking at a graph, we're going from left to right when we're talking about our slope. That would mean that this truck would be driving uphill. Uphill would be a positive slope. On this one, for example, we are driving from left to right, but instead we're going downhill, and downhill would give us a negative slope. So that we can tell if we're going up or down by our positive or negative. If something is completely horizontal, it has zero slope. It's not going up, it's not going down. And if something is vertical, straight up and down, we see that it's undefined. We'll see that when we end up doing our rise and our run right here. Now this is a phrase that I like to help keep me organized when I'm looking at a graph. And I'm picturing some stairs. If I draw a set of stairs and I want to know the steepness of these stairs, I need to measure two things. I need to measure how far a stair goes up, and I need to measure how far a stair goes over. And by putting those two things together, it gives me the total steepness of the staircase. Well, we call this up and down rise because you rise up in the air, and we call this a run because you run from side to side. And when we organize that in this, we get our rise and our run. All right, let's take a look at a graph, and I'm going to use those to figure out a slope. So when we're looking at a graph, it doesn't matter which points you use, just pick two very convenient and easy to find points. I've highlighted those right along here. So I'm going to pick a point right there, and I'm going to pick a point right here, and I'm going to figure out my rise and my run. So the rise, I'm going up 1, and the run I'm going to the right 3. Now, I need to decide if those are both positive and negative numbers. Now, with the rise, since we're going up, that's the positive direction with our y. So my rise over run will have a rise of positive 1. And our run is going to the right. The right is also the positive direction for our x-axis, so that will be 3. And our slope turns out to be 1/3. Now that's a positive number, and just like with before, we see that we are going uphill, which gives us a positive slope. Let's take a look at a second example where we end up having a negative slope, so we can see how that works out. So I'm going to just draw 2 points on here to give us that negative slope. We're going to use those, and on this example, we can see that we're going down and to the right. Well, we've gone down 2, and for the y-axis, down is the negative direction, so that's going to be a negative 2. And the run would be 1, 2, 3, so that would be 3, and again, it's positive because we're going to the right. So if we organize those, that would be negative 2 over 3, and a negative divided by a positive number ends up being a negative number overall, which we can see matches what we decided on our negative slope, that we're going downhill from left to right. All right, let's take a look at a table of values, and we need to be able to find the slope from this table of values as well. So I've given an equation right here, and in the function notation lesson, we learned that we can plug those values in right here to get our values over there. All right, so on this one, if we were to graph these points, we would have 0, 0, 1, 2, 2, 4, and 3, 6. All right, so there's our line right there. I need to find my rise and my run, so I'm just going to go from this point to this point, and I've gone up 2 and right 1. From here to here, I again go up 2 and right 1, and from here to here, I again go up 2 and right 1. So like I said, it doesn't matter which points you choose as long as you count correctly. Okay, so our slope on this one, organizing it as rise over run, would be up 2 and over 1, or 2 over 1. We could also just write that as 2 if we wish. Okay, you might notice that this 2 matches the number that's right here. It also matches on the table where we're increasing 2 for our y. Each of these increases by 2. And we're increasing by 1 for our x. So if you see that with the rise and the run, you might not have to graph it. I do like to check on a graph just to make sure that I did everything correctly over here. All right, and this will lead us to our next idea, where you will see equations that look like this. Y equals mx, and we're going to add some more to this in just a minute. But that m right here gives us the slope. So we could just look at this equation right here and see that that 2 gives us the slope. And that comes from these calculations right here. Each time our x value increases by 1, when we multiply that, it will end up increasing our y value by 2. So that gives us the slope there. All right, we're going to use this to graph some lines in our next lesson. We're going to introduce the y-intercept as well. But this is the idea behind slope. We're going to come back to rise over run for a lot of our lessons. And I thank you very much.